Continuing with our discussion of parent function transformations. So from the last two quizzes that you've had, we've learned that shifting moves the graph. So remember that this is going to move it left if there's a positive h, right if there's a negative h, up if there's a positive k, and down if there's a negative k. Stretching and compressing changes the shape of the graph. It makes it skinnier or fatter. And remember that if the absolute value of A, we only say absolute value because we don't care about the sign of that value. But if it's bigger than 1, it's a stretch, which makes the graph thinner. If the absolute value of A is between 0 and 1, that makes it a compression, vertical compression, which makes the graph wider. A reflection flips the graph over the x-axis. This occurs if A is negative. Now, something that we are going to learn in this section too is that if linear, it can flip over the y-axis with a negative A as well. So just reiterating, I've got our equations there for the main parent graphs that we're going to need in this particular section. And again, all of these refer to the variables that are mostly here. Remember that for B, that negative B is both right and down. So whichever one happens to be a choice. A positive B is meaning both left and up. None of the others have that. Another thing that we talked about before, but I want to reiterate, is that on the reciprocal function, that if it is a compression as opposed to a stretch, the A is going to be in the denominator, and it's going to be in the numerator if it's a stretch. Okay, so in example 1, we've got some multiple choice ones. So which equation shows the stated transformations to the parent? So in A, we have the reciprocal parent, and we want the one that is vertically compressed by a factor of 1/3. So vertical compression on a reciprocal are the ones where we have an A multiplied in the denominator. So here I have an A in the numerator. That would be a stretch. This is a shift, so that doesn't work. That's a K value there. And so in g of x, I see the 3 is in the denominator, which means I've got 1/3, 1/3. So this one is going to be my choice. This one would be a shift down. So that does not work, but the third one is our compression. Then B, f of x equals absolute value of x shifted left 3. So absolute value, remember that left is positive h values. H is inside the bars. So these two are inside the bars. Left tells me it should be plus, which means this one right here. This is shifted right. This is down. And this would be up. F of x equals x shifted up 7 units. Now, this is a linear, which means up is going to be a plus on the B. It also could mean left, but we want a plus on the B. These are both multiplied, so these are stretches and compressions. This moves it down or to the right. This guy right here moves it up. Then finally, for example 1, f of x equals x squared, vertically stretched by a factor of 5. So quadratic, the a value is in front of the squared and it's multiplied. So that eliminates the bottom two because these are shifts up and down. Those are not vertical stretches. Then if I go back, stretches are when the absolute value of a is bigger than 1. So here, 1/5, that's not bigger than 1, but 5 is. This one would be a compression, which is not what we want. So we've circled our vertical stretch. All right, in example 2, we're writing them ourselves. If you apply the changes below to the stated parent function, what is the equation of the new function? So in A, we have the linear parent function. We want to vertically compress it by a factor of 2/3 and reflect it in the y-axis. So again, what I wrote up at the top, that linear, a being negative could also be a flip over the y-axis. It doesn't have to be the x-axis. So that means this guy is going to multiply by -1. A vertical compression by 2/3 is going to multiply by 2/3. So we're multiplying by 2/3 and then multiplying by -1. So multiplying by 2/3 would give me this guy. And then I'm going to multiply by -1, which gives me this for my final answer. Now you can do that all at once. You don't have to do it in 2 steps if you'd like. All right, last one. F of x equals 1 over x. So this is our reciprocal parent function. We want to shift 6 units right and 11 units up. So right is an h value, and we know that we want it to be negative. So a negative h is going to go to the right. So g of x equals, I know it's going to be a 1 because I don't have any shrink or compression or stretch. So x minus 6, that's going to shift it right. Then it says 11 units up. So k value to go up needs to be positive. So plus 11 on the end there, and then this would be my changed function. All right, hopefully you're really getting the hang of these parent graph transformations, and make sure you ask if you have questions.